All right, let's introduce ellipses. They're not too bad to work with, especially what the lesson's going to ask you to do. Again, pretty straightforward, hopefully. So, ellipses, as we've defined parabolas and circles, kind of give a formal definition. Set of all points in a plane, the sum of whose distances from two distinct fixed points is constant. Okay, so there's two different points, each of is a focus. Plural of that we call foci or foci. And we can have a horizontal orientation where it's elongated along the x, or a vertical where it's stretched out along the y. And you can move these around, of course, just like circles. All the ones you're going to work with, though, in today's lesson are going to be centered at 0, 0, so kind of nice for you. Okay, I would encourage you excuse me, to pause the video right now and sketch these out in your notes and label all the parts they've got here. There's quite a bit going on, okay? So I'd encourage you pause, sketch these out so we can talk about them, all right? So, in our ellipses, we've got a lot going on. So stretched out in the horizontal direction, each end point is a vertex. So this over here would be a vertex as well. The shorter axis, okay, we've got a covertex. So down here they did label it covertex. So we call those covertices and vertices, just the plural forms. So this distance from our center to a vertex is A. From center to a covertex is B. And notice they've labeled points F, so this is a focus. That is a focus. Combined they are foci. And so that definition, you don't need to worry about this, but if we took any point, so if I dropped that distance, I dropped over there and I added those together, that would give us some value. That would be a constant for any point on here if you drew it to each focus and added them together. Now let's talk about this focus, C units. Okay, so if I went this distance right here is C units. Now that don't confuse this. C is the center, but this distance from the center to the focus has a value of C. How do you find that? Okay, let me show you. You use this relationship a squared equals b squared plus c squared. That feels a lot like Pythagorean theorem, and it actually comes from Pythagorean. The letters are off a little bit though, okay? So let me show you. So if we chose any point, actually let me just do it this way, okay? So I'm going to draw a triangle. I'm going to make a right triangle right here. So of course this would be a right angle. So this distance right here would be B. This distance would be C. And this distance, the way the math works out, is actually A. So this longer side is the hypotenuse. That's why A squared equals B squared plus C squared, okay? So remember, for an ellipse, A is always the longest side. Let's go look at the equations. Standard form of the equation. So these look a little complicated. Don't stress out about them, just write them down. So x minus h squared over a squared, y minus k squared over b squared equals 1. That's if it's horizontal, so it's stretched out in the x direction. And then this other one's very similar. Notice the only difference, a and b switch places. Okay, that gives a vertical orientation. So how do you tell if it's horizontal or vertical? Well, just look. If the bigger number is under the x part, then it's horizontal. If the bigger number is under the y part, then it's vertical. Okay. I wrote a little question, a couple questions down here I want you to think about. So maybe pause and think about those. Now, I wrote the standard equations here. Everything we work with in this lesson is going to be centered at 0, 0. So that means hk is 0, 0. So this would have the simplified form x squared over a squared plus y squared over b squared equals 1. Or for our vertical, x squared over b squared plus y squared over a squared equals 1. So they're going to be simplified quite a bit. But again, I thought I'd just show you the actual form. Circles, we saw both forms, but the ellipses, they choose to only have the center at 0, 0. So they're just kind of making it a little simpler on us. Let's look at a couple examples. An ellipse has a vertex at 3, 0, covertex at 0, negative 1, center, the origin. Write the equation. Okay, I like to just visualize. Let's do a quick sketch. Vertex, so again, let's do our center. Vertex at 3, 0. So 1, 2, 3. So there's a vertex out there. Covertex at 0, negative 1. So if this is out here, that means the other one would be 3 the opposite direction. This one's here, we'd go there. So if we kind of sketch that in, kind of hard to sketch ellipses, I'm just freehanding that. What would that look like? Well, let's think about it. So my A value is 3, right? That's the longer side. My B value is 1. So we can write the equation pretty easily. So x squared over 9, 3 squared, plus y squared over 1, and you don't even need to write that one if you don't want, equals 1. Hey, there's the equation. Let's check that. Let's bring Desmos in over here. So I've got that equation I've already typed in, and I'm zoomed way out. Let me zoom in here. So hey, there's an ellipse. Let's click on it. So 3, 0, right? Negative 3, there's negative 1. Hey, that looks like that ellipse. Not too bad, okay? So let's do another example. Write an equation in standard form, an ellipse that's 50 units high, 40 units wide. 50 high, 40 wide. So let me just sketch an ellipse. Now it's not going to be that exaggerated, but this whole distance they're telling us is 50, and this whole distance, again I didn't draw it to scale even close, would be 40. So what does that mean? Well, if this whole distance is 50, can you tell that A would be 25? It would be half that, right? If you went from the center. And B would be 20. Could just be half of that. And so if we wrote the equation, x squared plus y squared, of course it equals 1. All the equations equal 1 for an ellipse. That's convenient. B, let's see, it's stretched out vertically, so A has to go under my y squared. So if you square 25, you get 625. If you square 20, you get 400. Okay, that looks like the equation there. Okay, let's try it. I've got this. Let me bring up in Desmos here too. And let me turn that on. Now let me zoom back out. That's why I was way zoomed out before. Okay, so here's our ellipse. Go up here, 25. 25 plus 25. Hey, that would make 50, wouldn't it? And out here, 20 and 20, that would make 40 wide. There is our equation. Those are pretty typical of the kind of problems you'll see in the lesson and also in the practice assignment. It'll also have you identify some graphs. Hey, no problem. I just type them right into Desmos. Again, hopefully you can recognize the key characteristics from what I've described, but also just go use Desmos. The lesson's also going to have you do a few things with the foci. Not bad to use. You just use this relationship here, okay? C A squared equals B squared plus C squared. That's how you can find those foci if you need to. So I hope that'll help you out with the lesson, okay? Good luck as you go through things. Of course, you have questions, you can always reach out to me.